All right, that's great. So I am thrilled to introduce our esteemed speaker today, Associate Professor Dr. Zulkifli bin Zainul Abidin from College of Engineering, IUM. And he holds an undergraduate degree in Computer Information Engineering from IUM. And he earned his master's and PhD from USM, Penang. And he has extensive experience in the field of robotics and engineering. And he has collaborated with prominent organizations such as PDRM, Proton, then there's Petronas, and more. So he secured over 5 million ringgit in research funding, and as the director of Center for Unmanned Technologies, CUTE, and also senior member in IEEE, his expertise spans underwater, ground, and space robotics, intelligent control algorithms, and innovative sensing devices. So we are in for an enlightening session. So please join me in welcoming Associate Prof. Dr. Zulkifli bin Zainal Abidin. So Dr. Zulkifli, the virtual floor is yours.
Bismillahirrahmanirrahim. So thank you, Sister Tahlil Amina. Welcome to I think this is my first webinar title dedicated directly to the mechatronic. Previously, I'm working on the commercialization talk on the product development. This is, I think this is new to me. I'm prepared quite extensive slide for today. Hopefully you enjoy and understand what the mechatronic world it is for the future. Okay, so my content straightforward is what is mechatronic, some review on the historical perspective, and then what we have today, which is already advanced, and then we predict some future technology for mechatronic advancement, and I will share my experience, and lastly the challenges, and of course we're going to have our own Q&A session to everyone. So what is mechatronic? So the term itself quite jargon word for those who are not in engineering. But then those who are engineering quite also not really understand what is the branches of mechatronic. Some of them say that it must be a computer with a mechanical. Some of them say that the human-robot interaction, electrical, everything should be embedded under mechatronic. But then to simplify the understanding, essentially we can just simply use this term, which is the mechanic plus electronic. So we take the word into one acronym, which is mechatronic. So it is basically the integration between 6 components. First, we must have a mechanical, and then we have electronic. It can be like a microcontroller, processor, etc. We do have sensor, of course. We want to sense something, and we actuate and make it move. Number 5, we have a control algorithm, of course, to make sure that the interaction between the mechanical and electronic work. We must have a certain instruction code to do that. And finally, we must have a human-machine interface in order to control and to interact either on phone or physically or virtually. Okay. And then the targeted product of mechatronic is actually a smart product for the consumer, or also the smart system. Okay, so the mission of mechatronic movement is actually to improve quality of life, to enhance product quality, and replace manual labor tasks. So today we can see that all industry sectors, particularly in automotive, aerospace, quite a lot of interest in mechatronic recently. So we can say that all departments we have in faculty, including civil, including material and biotech, all of them need a mechatronic integration today. So take a look at this sample of mechatronic device. Can we say that this microwave is mechatronic device? Okay. So I asked ChatGPT, and then ChatGPT said that the first one is a mechanical component is there. There's a turntable, door latch, and hinge. And then the component number 2, electronic part, which is a microcontroller and microprocessor, communicate with the 240 volt, and then how to operate the sensor together with the actuator. Okay, and then number 5, there is a component of smart algorithm. Once the time is out, or the what the algorithm mentioned that this is something happening beyond the operation, like suddenly the door latch is open, so it will stop, so that it ensure it operates safely. And finally, the screen, you can do the adjustment on the setting, etc. So by having these 6 components, we can say that microwave is also a mechatronic system. Other example in our daily life, like a washing machine, dryer, okay, even our printer. So we have a mechanical, electronic, sensor, actuator, control algorithm, and also our GUI to control the scanning or printing. And also, like those who have this tiny robot at home, is also is a mechatronic system. And then when we see in our transportation system today, you can see the LRT Gombak Rapid KL have there's unmanned train, isn't it? So basically, it is also can be monitored and controlled remotely from the office, from the HQ. Same goes to the RFID system and smart tag. There is a gate system and country. It also can be override and monitored by the central station at Plus Highway. So these are also example of mechatronics. So what we can see that mechatronics is almost everywhere in our daily life. So while preparing this slide, I found that okay, it is not only the system itself, but also all the product we see in front of our eyes today. Everything is made by the mechatronic system. Like for example, you see the pen. Okay, I have a pen in front of me. So let's take a look what we have in the production line, pen. So this is how the pen is being produced or manufactured. So this coordination of the actuators, sensor is a good algorithm so that it can produce quite a number of pen within the shift. Okay. So another example, what can see, even Arduino candy factory. Now can see candy factory. Okay. Sorry, my kid is sometimes using my laptop. Okay. So candy factory, even if you want to do the packaging, all those consumer product available in market, before we reach our table, mechatronic is behind it, okay, to produce the end consumer product, including packaging. Okay. So what we can say that it's almost everywhere. Okay, this is what I have in my phone. My house, this is my house, for example. So I buy a few component of smart controller. I change all the plug aircon system in my house so that I can control remotely. Like for example, in Wi-Fi, I can turn on and off my Wi-Fi so that my kids, okay, do not have an access, okay, after 10 p.m. Okay, and then we turn on again after 5 a.m. For example, I can monitor my aircon power, and then I can control my robot vacuum. Here is I have a robot vacuum at home. Can see the coverage and then the replacement of the parts that needed, and then I have a CCTV that I can monitor remotely. Okay, these are all the mechatronic system in my pocket today. Okay, cars also have a lot of mechatronic system. Like for example, it's a TPMS, tire pressure monitoring system, whereby it will sense the pressure of the air inside the tire, and then wirelessly send to the ECU, and ECU will display on the LCD. These are all the what we can see that under one product in the car. They have 100 of mechatronic product on it. Okay, let's take a look about the historical perspective of mechatronic. So during the first industrial revolution, okay, we rely so much on the mechanical that we controlled by man, extensive labor cost. Okay, so what happened? Sorry. Okay, during the boom of semiconductor industry booming. So what we can see here, the device of electronic or the controllers is getting smaller and smaller. Okay, you can see us getting smaller and smaller meter during 2010. But what we can see, this IBM unveiled 2 nano chip. Just imagine that now the mobile phone, okay, the chip is as small as a, okay, 1 grain of sugar. It's too small. Okay, even the development of the robot also as small as the hole of a needle. So what we can say that over the time, there must be a advancement from another system that's supporting the mechatronic system. So because of the advancement of communication, advancement of the chip, advancement of the mechanism of mechanical development, so it foster the development of mechatronic for advanced product and system. Okay, so what we can see Industrial Revolution 1, 2, and 3 about the internet now is everything is automated, is much more complex. Okay, where is the term mechatronic is coined? Was coined by this Japanese guy working on the Yasukawa Electric Corporation. He's the one who used this term before. Then Japan, as you know, that is famous about the robot. They are the one who exploring so much on the robotic and automation in early 1970. And then in 1918, okay, officially the mechatronic began to be in our academic discipline in university. For your information, Kuliah of Engineering IUM is the first faculty in Malaysia. If I'm not mistaken, together with UTM, the same year, we are the one who proposed the first bachelor program in mechatronics in Malaysia. Okay, and then it's continue to revolutionize. Now we have aerospace, healthcare. Everyone want to be in line with the mechatronics. Let's take a look what we have today. Okay, most of the production line for the car is already look like this. It's a collaborative robot try to assemble the complete car system. Okay, most of the warehouse today is operated by robot. Some of the company in Malaysia like Shopee and Lazada, they are also using a lot of AGV robot. Okay, the dairy farm, how to produce the milk automatically using a mechatronic system. Okay, in Japan, the vending machine is already advanced. Okay, they have so many vending machine everywhere. So vending machine also a part of mechatronic system. Okay, when we take a look the metric of the robot work as a individual component everywhere from defense, industry, security, medical, transportation. Okay, when we want to category a robot, we can see that some robot is flying, some robot is swimming, 4-legged, 2-legged, 4-wheel, arm, and head. Okay, this robot can stand alone and work at their own time and pace. Okay, if we categorize the robot by their own field of operation, UAV is for flying. Okay, these are all the product is already available in the market. Okay, it's not only a research but already available in the market. Some of the product has been displayed here. USV or AUV is a surface boat or sometimes looks like a submarine. This is what we already use in the industry. Unmanned ground, meaning that it will walk or move on the ground. Okay, we also have a robot that can do both. Okay, swimming and also on the ground. Okay, what about the moon landing project? Okay, there's a lot of mechatronic system on it. Okay, for your information, this is what happened in India. Okay, it is still new. Okay, India managed to send their robot Chandrayaan-3 on August 2023. So it is a lot of mechatronic system involved, from transporting the robot using a rocket, and then orbiting the direction towards the toward the moon, and then to deploy the robot. Okay, it's not an easy task. Okay, you know that the time is very critical. Okay, how can we use the mechatronic system to be safe, which is out of our eyesight view? So it looks like it's not that easy job. Okay, this is rocket science in mechatronics. Okay. What about the what we have in the sea? In the underwater, we have a lot of robot is already working in industry. This is not the future. This is already happening now. A lot of company, especially oil and gas and survey company, they are using this kind of robot to do their field operation. On AI, for your information, is a branch of mechatronics as well. Okay, AI today is already embed most of the robot and automation system is linked to the AI capability. Okay. The 3D printing that we have in lab is small, isn't it? But it's already in the market for the past 10 years. Now, the construction companies start building a large scale of 3D printing so that they can construct the house. Okay. Remember, I'm showing you the smart house system. Now, for your information, most of the new hotel building equipped with this smart building system. Okay, all the building is ready with the EV charging. In Singapore, most of the building already have this EV charging. They have a smart air conditioning system. They have a lighting system to control and then to maintain the temperature, utilizing the free source of energy, for example. This is what happened in UK. Okay, autonomous electric ferry already began commercial. This is what happened for the past 3 to 5 years. Okay. Even the offshore oil and gas platform also now is already unmanned. So what happened is it's no longer there's no more crew in the oil and gas platform. Okay, let me show you this video. This is in China. For them, this is the first platform. But for the European and for the US, they have quite a lot of oil and gas platform using this method. Unmanned offshore, meaning that there's no man on the platform. Everything is remotely controlled or autonomously moved. The tubular piping, the extraction of oil, everything is intelligently controlled by the system itself. This is what we call unmanned offshore gas platform. This is also a mechatronic advancement. I think most of you have seen this in Malaysia now. The drone has been heavily utilized in paddy field. Okay, this is no longer, drone is not only for photography now. In Malaysia, this is, I have a friend, he was a mechatronic student as well. And now he's operating this drone at Kedah. The average income is around 5,000 ringgit. Okay, they are simply operating the drone to spray the pesticide. Okay, so in the Europe, they already have autonomous tractor to do the field agriculture work, and also some for some scale of farming, like indoor farming, etc. They're using a small robot to run the operation. This is what happened today, not future. Okay. Okay. Exoskeleton also has already take place in the industry. Those who need this special suit will increase the strength of the body to move link to their brain or link to their muscle. Okay, so those who can't walk now can do the normal stuff, but with the assistance of the biomechatronic system. Okay. So now the question is, what will be the future trend and research? Okay. So I try to take a few examples. What I can say that the trending is already in line. What we see for the past 5 years, the prediction will be one of it is this. This is the what the things that might worry some of the uh, academician, those who are studying a future study of the technology. They are afraid of is this possible that one day the exoskeleton is not only helping us to move our hand, but also which that change our genetic and our brain and also the DNA. Okay, there's a possibility that the Robocop and Iron Man integration with the our brain and the muscle will be there by 2040. Looking into the trend, as you can see, yeah. So now we are here at BCI. We can control using our brain to computer interface. Okay, the toy, you can buy a toy in Shopee. You can control the spider robot using your brain. You put it in your head. You can control that. It is already happening. You can buy that product from Shopee. Okay. Remember the future farming previously is separated, meaning that the UAV drone do the drone work only. The UGV tractor used for their own product only, for their own work only. But in the future, everything will be integrated under one system. So this is the future farming will looks like. So one guy is remotely control and see the operation from the house, and everything is integrated. So what we can see that in the future, most of the mechatronic system from a single system will be integrated into one large system. Okay. Remember the human-machine interface that I will show you just now is not only can be controlled by this man for to see what the environment. Okay, some people can use the AR VR to control the tractor remotely from distance. Okay, this is what happened in Korea and Germany. They can control with the advancement of the communication from 5G to 6G in future, they can control seamlessly in real time. So what happened next, if you can see this trend, it will lead to the construction site of the future. Construction site in the future, all the system will be the prefab integrated delivery system, meaning that if the cement or the material is almost reached 20% or 50%, and then we need to supply it as soon as possible, you don't longer need the supervisor to count it for you. The system will count automatically and ask the supplier to send it autonomously. So this will be the future construction start. Everything will be integrated and easily controlled from a distance. Remember about the smart building? I have my smart house, and then we have smart building. But by 2024, now most of the city like Cyberjaya, they're also starting to build a smart city. What is a smart city? Smart city is component of smart transportation. Remember, we have a LRT station, standalone system. we have a car, autonomous car system. It's a standalone system. But the smart solution, smart city is actually a merging of the system under one holistic control. So the most of the building will be the green building. We want to see that we want to reduce the carbon footprint. Building management system is all, as I mentioned before, is a smart building, can control the power itself. And then to control the air pollution, everything is integrated with a smart grid. How much power do you need? Extra power, you can save it for another grid. And then real-time update for the user. We can control our house remotely, and also the government can see the pattern of the utilization of electricity for the underground subway, for example. Everything will be integrated, including the detection of the water leaking, earthquake early detection, landslide detection, everything integrated until the traffic monitoring control, fast lanes, smart lighting, and etc. So this will be the integration of the individual system. Okay. The autonomous car in future, the prediction will be the much more towards the robotaxi market, whereby, let's say for example, you buy the car that can do the autonomous. So while working now, let's say for example, I'm working right now, but my car is also working outside. Okay, what I mean working outside, someone can use it as a Grab driver, can call my car to send it from one place to another, and then I can get my money while I'm also just simply sitting here talking to you, but my car also working for me. This is what is going to happen for the future. And then for the future also, they are targeting for higher speed. Okay, higher speed of transportation. This is already happening. Now it is not only the drone for entertainment, but in future, drone also can be used as a personal aerial vehicle. So you can move, you don't need to have a pilot license, okay? It is just a transporter for you to send you from one place to another. Okay. This is what happened in Mars. Okay, just imagine that the exploration of NASA using their Perseverance robot is already, I think, 2 years already. Okay, in future there is a possibility either they want to colonize, or you can extract out the mineral from Mars, bring back to Earth. There's a possibility. Okay, a lot of mechatronic system we need to be there in order to support this mass direction. Okay, the merging of system for unmanned system will also help the defense industry. Okay, including the wearable device for their soldier. For the ship, okay, they already have a target that by 2020 they have a small ship. We can do the autonomous movement, remotely control, and then can do the task like a survey work and do the transporter system. By 2025, the vessel is getting bigger. By 2020, all the cargo, all the ship, there is no captain on it, because captain is no longer AI captain. It will be the AI captain. Captain will remotely control from the operation of onshore, and then everything is integrated. So now the question is, where are we now? We are a consumer, we are the one who use the technology, or we are the one who produce the technology. You know that if we produce, we are the developed nation, okay? Our intellect, okay, can be paid off, will be paid off by the innovation that we have. As a mechatronic, I will show you that some of my experience. I have a lot of project for the past, since I back from my PhD study. So I have a lot of industry grant and collaboration. I can show one of it. So this is my strength. Okay, I'm working on the unmanned surface vessel, whereby this company have a problem because of they are using the man work to do the data collection on the sea. So some of the issue they have is they cannot work it over the period, like during the monsoon, like for example. So the demand is there. This company asked me to develop an unmanned surface vessel that can integrate with the existing instrument so that they don't need to go to the sea physically. So I'm using this robot. Okay, we developed this quite number of robot. This robot is assisting this company to bring their instrument and collect the data. So it is not an easy work because, you know, as I mentioned before, we need this marine background. We need the electronic background. We need so many things. Okay. And then, of course, in order to get a customer, you need to go for the showcase. Okay. We need to have more, not only one product. We must have a more mechatronic and robotic product in order to attract the customer that our capability is beyond what they are see. Okay. So back to my memory timeline. It is not an easy work. I started somewhere. It's around 2011. Okay, building the small boat. I try to make it remotely controlled and unmanned control, and then towards what you see just now. Okay, so it's a long-term process, more than 15 years for me to reach this point. I'm also working on the different kind of robot for the different industry, like a cleaning of ship hull, cleaning of the floor. I'm working with the Plus Highway for the automated car classification in the toll Gombak. I'm working with a company to develop the Mandibot with this process. So based on my experience, I see a lot of challenges and hurdles. Okay, some of it during your, I think most of you here is postgraduate student. I think most of you might see that the challenge is you start within the idea to prototype. Okay, you try to make it, and then you see that this prototype is ready for the market. Your mechatronic system is ready, but actually the the highest part of the innovation is to get a validation and production. In order to achieve TRL 6, 7, and 8, you need industry to collaborate. This is where your mechatronic system will be validated by the company in order to say that your product is proven, can be used in the actual environment scale. We don't want to see a product after a few months, you need a very high maintenance. So this is the hurdle that most of the researchers from the university very hard to reach the trial 8 and 9. Okay, some of us might think that mechatronic design is simple. What we see, and then we process it, and our muscle will interact. It's just simple like that. We have an Arduino, we give an instruction because with the sensor say like this, we move it, and then that's with the output. But in the reality, mechatronic design process is not straightforward. Okay, because of the component, some of us are using a trial and error, but when it comes to the stage 4, whereby the mechanical, electrical, and software part must be synchronized. Sometimes during the testing, we blame that this is electrical problem, this is software, this is mechanical problem, and again and again iterate. Okay, so what we have, the crucial part is here. Actually, we need someone with a system integrator. We have that guy who should be able to solve the dilemma between stage 4 and 6. We need more guy on this system integration part that can understand the whole process of mechanical, electrical, software, and testing. So that's why the importance of the cross multidisciplinary team. Another challenges I facing because of the regulation. Some regulation is still not mandated in the country. Like for example, we still cannot deploy the autonomous car in Malaysia because the facilities, the JPJ, the MyROS, we don't have a proper regulation yet. Like for example, when I'm building the Medibot, some of the medical device you need to pass a certain standard in Medical Device Authority Malaysia. But if it is not gazetted yet in the parliament, you are not allowed to do that. Some of the communication system that I use in my robot system, unmanned system to communicate from the ground station to the boat, the frequency that you use is not in the MCMC, not in the multimedia communication book yet in Malaysia. This is something what we consider chicken and egg. We do not know why, but we stuck somewhere here. Okay, and then most of the mechatronic system, especially in robotic, still have an issue with the insurance and warranty. What I mean is, let's say for example, in order to deploy my boat, all the boat in industry must have their own, like a ROTEC. But since the regulation from the our Ministry of Transportation is not ready, so I cannot register my robot boat. Because of that, I don't have a insurance or warranty to work to deploy my robot. So what happened now? I have a very high risk in operating my boat if the boat, okay, lost or missing out of nowhere in the open sea. So I cannot claim any warranty. This is the main challenges. Okay. Next challenges to me is this is the thing. Okay. What Malaysian Gen Z employee want from their work. It's very hard to retain a good mechatronic engineer today. Okay. This is in Vietnam. She said her experience 4 times changing job. Okay. Within 1 year, change so many jobs. Okay, this is happening not only in Malaysia, but also in Vietnam. This is what happened in Malaysia. Gen Z, generally supported by their parents, bringing digitalization. This generation is very different. So, as a company, as a researcher who train the technical work on the mechatronic, let's say we train about 4 months already, but suddenly the skill workforce is already not in my table. I need to train again and again. This is the dilemma on my side. The company now is learning to understand the Gen Z, how to easiest way to win their heart. Okay. So I would like to announce that I'm going to for Kuliah of Engineering particularly, I'm going to establish a new club. I'm going to establish a new club in Kuliah of Engineering, whereby this club will embed your CGPA. Okay, what happened? I can show here. I'm going to recruit a junior, first year and second year. So what happened is your senior in third year IDP1 and IDP2 will leverage that credit. That will leverage that credit to join any competition or to do the industry project. So if the industry like your solution, if you win the competition, your 6 credit can be converted into CGPA. If you score A, meaning that 6 credit A. Okay. For those who are joined in junior, your class project, your class module, I will talk to your respective lecturer, like for example, the CAD drawing lecturer or the coding lecturer. You will supporting your senior third year for this competition or the company product. So you will get some carry mark from your class project. And then during the internship, I will hire you as the apprentice with a good allowance. Okay. During the project, everything will be funded. And funded by using the industry-grade facilities. By using the industry-grade facilities, your competition product, your product is close to the industrial relevant solution. Okay, during your 4th year, now you have an option. Either you want to continue your internship project company can pay your monthly stipend allowance plus if you score a good grade, the company will say that this product is already launched as for our market usage services. Then there's high possibility that you can score A in your credit, and eventually you will be my apprentice related to marine industry for postgrad and also my future engineer. This is my my introduction. It is supported by the IEEE OES Malaysia, and then my spin-off Barakuda Lab and also under Qt Maritime Robotic Lab. So for your information, I already lead this team before. It happened last 5 years. We won the ROV competition. We won the UAVC Autonomous Underwater competition. We're going to win this surface vessel competition. Most of these students is already excellent to me. Their work after 5 to 7 years, their salary is already more than 6,000 ringgit, 6 to 7 ringgit. Some of them is already work abroad in US, in outside because I've tried to give the best of the experience for them to do the multitasking work. So when I do job hunting today, it looks like in the job street, I search a mechatronic. There's a 522 job everywhere. When I search in the Glassdoor job in Malaysia, 481 mechatronic job engineer is opening now. This is a yesterday search. In the LinkedIn, we have 411 result. I still also have every month, my friend in industry is calling me asking for the best engineer that they want to hire. So meaning that the work in mechatronic, the industry in mechatronic is expanding now. But we want to see the postgraduate and undergraduate student that can meet the industry expectation. I think that's all for me. Quite a lot of slides. Hopefully we can do more Q&A sessions so that I can give you a better insight what you have in your mind that I can answer. Okay, over to you, sister.
Thank you very much, Dr. Zulkifli. It was such an enlightening session. We got to see so many perspectives of mechatronics, starting from our day-to-day life to the space, underwater, practically everywhere. And then even AI is a part of mechatronics, and it is a lot for the future study scholars who are seeing so many expansions in mechatronics, and there is generative AI as well. So there is a lot for the future studies scholars to see, okay, the possibilities are expanding and how to control it. So, and I'm also very thrilled to see the opportunities are in the mechatronics field. And are there any questions from our audiences? You can please raise your hand, or you can just put your question in the chat. All right, so if there is no question, I have a question. So, Dr. Zulkifli, what do you think is your opinion in our role? For example, we can see that there's so many expansions happening in this field, in the mechatronics engineering, and what could be our role in this? How to participate in it, and how to help in the control? You know, there's so many possibilities in the future. So how do we?
Okay. Okay. For your information, market today is dynamic and integrated. Dynamic and integrated, meaning that most of the industry they cannot run from the IoT, for example. They cannot run from the electrical and electronic. I think your role as a postgraduate, okay, your role as a postgraduate, I know that you have two dilemma. One, to finish your, to get your certificate, okay, as a master thesis, to get your work on the publication done, okay. Well, but some of you might think that, do I contribute something to the product development? Okay, this is like something very hard to balance. Okay, and then to me, in order to penetrate into the mechatronic, it is much more challenging, much more challenging. meaning that in the perspective of you need to work with a quite number of people. Okay, if you work alone, okay, I can say that there's high possibility that your system will not work. I know most other master students work alone. Most other master students stay in their cubicle. Okay, and then how to go beyond the lab? So this is the question. So try to work beyond the lab. Is either, I know your project is your own masterpiece. Okay, but try to collaborate with someone. Okay, because the art of mechatronics is a collaboration, integration of everything. Okay, so try to reach that level. I think that's very simple. If I give you complicated, it will getting complicated. This is simple. Try to collaborate beyond the lab work.
Totally.
Okay.
This is such a fast moving space, and we can only go forward if we collaborate.
Yeah.
And yes, thank you very much. And is there any question from the field? All right, so we have come to the end of our session, and we're going to make sure we pass the video to our undergraduate students, because I can see there's a huge field of opportunities for them to dive into this, and also mentioned by Dr. Zulkifli, the opportunities for converting your internship grades into CGPA. So that's actually a very big opportunity. And yes, we will try to get many students on board. And thank you so much again, Dr. Zulkifli, and our audience. And also keep in touch for our future webinars, and we will get back to you. And also let's end this session with Tasbil Kefara and Sural Asar. All right, thank you so much. And this is Amina Tahrin. Assalamualaikum warahmatullahi wabarakatuh.
Salam.